3, finish up that today, then we'll finish up 10.4. And I'm gonna start touching on 10.5. We probably won't get to 10.5 completely. In fact, I know we won't. We'll start 10.5. And then we'll finish up 10.5 on Tuesday, start 12.1, and then 12.2 on Thursday. And then if we have time, I'll spend the last part of the class on Thursday. If you have any questions for me about the review. Okay. So remember that review is online. I don't have any questions answered. And the reason for that being is one, you're older math students than just a college algebra student, you're statistics students. Okay. But I want you to start trying to realize now that by using that review, you can look at the question and go, okay, where am I going to go to in the Hawks or my book to go find out how to do this? Same thing you're going to have to do on your final. Where did I learn this? So I know what button on the calculator am I going to use? What formula do I need to look at? X, Y, Z, a whole bunch of little things you got to go through in your head. Because statistics isn't just like, oh, I've got the quadratic formula, or this is what I learned in chapter 7. We're just going to go through this little synthetic division. No, you've got to remember, okay, it's a hypothesis test, but is sigma known, unknown? Is this a proportion? Is this a variance? Am I doing intervals? You know, man, is it normal CDF? Man, is it Z? So notice, it's a Z test, all that other stuff. So, there you go. So, very quickly, going to hit through this very, very quick, and then we'll get to some examples. Once again, we'll just kind of do, even if I can redo just a couple, sigma unknown. Okay, remember, you're not using a Z score anymore. You're going to be using that T score. Okay, you can do it one of two ways. You can either A, use the chart that's in your book. I give that to you on your final, or you can use your inverse T button, okay, that's on your calculator. Just got to be careful because it's going to ask for degrees of freedom. Degrees of freedom is always the number of samples minus 1. Okay, so be warned about that. This one obviously is showing sigma known. So there is your formula for if you're using this on your project paper. You're going to need that formula. It's for whenever you start finding the, where's that? That's going to be your test statistic. It's hard to say that very closely. You say test, you got to put a little pause. You start blending all that together. Okay. And then they gave you a whole bunch of other stuff to be to kind of be able to put into that. Another thing you're going to need to add to that if you're going to use your chart, you're going to need the degrees of freedom no matter what. Anybody remember the calculator button you use on this one? T-test, exactly. For 10.1, or sorry, 10.2, it was going to be Z test. For this one, it'll be T test. Okay, so that helps you out. For your project paper, you're gonna need to see it drawn. Okay, for your final, man, calculator all the way. Get it done quick. Okay, now remember, and because we're getting close to our final, the way you show your work is this. Pretend this is question 1. You just put question 1. You tell me what calculator button you used, but then you need to make sure that you tell me what numbers did you put in? What was your N? What was your degrees of freedom? What was your X bar? All that stuff, because I'll go in and look at it. Because remember, it's going to be Hawks grading. And if you show me nothing, I'm going to look at Hawks. I'm going to look at your work, your work, and go, well, they got this answer wrong. Well, where did they get it wrong? Oh, look, he used Z test instead of T test. But man, everything else is right. We can fix that with a conversation. I'm going to give you some points. But if I see nothing, you get no bonus. You get no, not bonus points. You don't get any partial points at all. So that's the way you're going to be able to get some partials in there. Okay. Maybe you didn't round correctly. Okay. I can see it. It's on your paper. Oh, look, you didn't round correctly. I'm going to give you some points because I want to help you out a little bit. It's not just going to be right or wrong. I can deal with that a little bit. You're not going to get it completely right, but I can help you out. Okay. So just got to be ready for that. So here, this can be for your project, but then for your calculator, of course, it's going to be T test. And just so you have it in your notes again, remember, you just go to stat. And you go to where? Test, right? And then you go to T-test. And just make sure that when you do that, make sure you have these stats highlighted in your calculator. Once again, left tail, right tail, two tail test, got to be ready for those. Okay. They look a little bit differently. Okay, just a little bit. Okay, this one looks a little weird there. Don't worry, I'll show you an example of that one. But that's where we reject. Okay. If we're using, remember, we have two methods to decide on if we're going to reject or if we're going to fail to reject. One of them is when we draw the picture, we have a little area. There's an area of fail to reject, and then there's a colored in area that we call the rejection region. So like just for an example, for clarification, if you have something for a left tail test, here you go. That right there is going to be your rejection region. And then here is going to be fail to reject. And that t-test is telling you, where is this thing falling in there? Okay, is it falling into your rejection part, or is it falling into your fail to reject? We also have, and this is your method one, you also have the p-value. Okay, if it says, and then which I'll show you here shortly. This one right here, method two. If p is less than or equal to alpha, that level of significance, be ready for that. Because what if they give you a confidence interval or confidence level? Well, that's not the same thing. You're going to have to do 1 minus c. Remember, c is equal to, like, say, 95. You have to do that 1 minus to get the alpha. The alpha is that shaded in area. That's your rejection region. That's the alpha. Okay. And good thing is through 10.3, or sorry, 10.2, 10.3, 10.4, and 10.5, this never changes. Not one time. It's always going to be as p is less than or equal to alpha. This might be something good to put on a note card. I don't know. You know, so that we don't forget it. You know. And I think we did this one in class, didn't we? Did we get to this one? The nurses one, or did we get to that one? Okay. Let's start working through this. I think we kind of did this, and let's kind of work our way through it because I'm going to draw it out. Okay. A children's clothing company sells, and yesterday I read this completely wrong, and I was confused for like 2 seconds. I put a children's clothing company sells hand smoked dresses, and I was like, "What are hand smoked dresses for girls?" And I actually asked some little girl in front of me, "What's a hand smoked dress?" And she goes, "Read it again." And I'm like, "Oh, smocked." Still don't know what it is, but it sounds a lot more better than smoked. So a children's clothing company sells hand smocked dresses for girls. The length of one particular size of dress is designed to be 23 inches. The company regularly tests lengths of garments to ensure quality control, and if the mean length is found to be significantly, here are the words, longer or shorter. Okay, so they're not specifically saying one or the other there. Okay, then 23 inches, the machines must be adjusted. The most recent simple random sample of 18 dresses had a mean length of 21.212 inches with a standard deviation of 2.67 inches. Assume that the population distribution is approximately normal. Perform a hypothesis test on the accuracy of the machine at a 0.05 level of significance. Well, we're so close to the final. Let's start seeing how you would parse this out. One, you got to decide what type of test you're going to use. Okay. Well, first off, you need to know, are you using mean, everything else? Obviously, right now we're in 10.3. You're going to go, well, it's mean. Yeah, but how are you going to know when you're on the final? None of this is in order on the final. Okay. Matter of fact, I think this is question 1. Okay. Something like that. So you start looking through it, and they start specifically mentioning the word mean. Okay. So you can go, okay, so I know I'm dealing with mean. And then you have to decide, okay, am I dealing with a population standard deviation, or do they not give me the population standard deviation? Okay. And as I told one student yesterday, read it like this. Look, the most recent simple random sample of 18 dresses, that's obviously speaking of a sample at that point. Okay. Had a mean length of 21.12 inches. Then right immediately, right after that, they start going, oh, and with a standard deviation of 2.67. Notice they never said these explicit words, population standard deviation. Okay, so you can go, okay, I'm going to have to be using a t distribution for this one. Okay, so we know that's what we're going to use. Yeah, and on this one, look, they give you the mean. Mean is always equal to 23. Then you have to decide, is it gonna be less than, not equal to, or greater than? Not equal to, and the specific word you're noticing is why? Yeah, longer or shorter. Okay, because that's gonna tell you what type of test you're gonna need, because when we get to chapter 10.4, I'm gonna show you the most annoying questions you're ever gonna find in your life is in chapter 10.4. It's like every single question has 7 parts. It's stupid. I did not design this. So whenever y'all get mad at chapter 10.4, don't get mad at me. I didn't pick that because I was like, this is stupid. Why did they make y'all do this? So, but it's a bunch of answers you kind of see already. Okay, so let's look at it. This says not equal to. Well, what kind of test would that be? Two-tailed test, exactly. Well, let's go to step 2. Compute the value of the test statistic. Now, 1, you can use your calculator, but 2, if you're doing this for your project, you're gonna have to show me your work. I almost want very little calculator work on your other paper. So let's look at this one. They give you to find a t-value, to find a t-score for your data is gonna be t is equal to x bar minus mu, all divided by, well, instead of a population standard deviation, which would be sigma, they're giving you S because you do not know the population standard deviation at this point.
Let's see.
Let's come in here, take the square root of n. It's a good point at this point to go ahead and start writing down all the information you know. We know we have a mean, and the mean is what?
Wait, what?
What does the population mean that they want you to have?
24.
24, exactly. And then they give you an X bar. That's going to be your sample mean. Which if you notice, when they start talking about samples, that's going to be your 20.36. They give us a sample standard deviation of 4.83. They give us an N. Our number of samples is only 18. By the way, if you remember, to find out all conditions are met, you have to have samples over 30 or what? Yeah, right there. That's how come they put in that there, right there. That approximately normal. If you're less than 30, your distribution has to be approximately normal. Okay? And because if you're using your chart, if you're using your book, or if you're using the paper I give you, you're going to need degrees of freedom, which is always your n minus 1, which is going to be
16.
Oh, was that one up to 17 or 18 there? Very good. Not even 18 up there anywhere. My brain just said, nope, we're gonna have 18 for that. All righty. So let's start going here. Let's start figuring everything out here. Be very careful. Notice we're gonna be rounding to 3 decimal places. So we're gonna start putting our information in here of 20.36 minus 24 divided by 4.83 square root of 24. That's gonna end up being negative 3.64 divided by 0.9860. You should get a t-score of negative 3.69. That is your test statistic. Okay? So if you're wondering what that is on your project paper, that's how you find your test statistic. It's either gonna be a Z or it's gonna be a T, okay? So right here, negative 3.692. Now get out your calculator. Make sure you can do it on your calculator. Go to stat, go to test, go to number 2. Number 2 is your t-test. And start putting in all the information you were just given. You're gonna notice when you're doing your calculator, you get to, first off, for your t-test, you're going to notice that it gives you some values here. Go right down, because I hit draw on my back now. Notice it gives you a t-value. The t-value is a little different, okay, than what you got. Hawks will count it right either way. The reason the t-value is different for the one you did, Hawks is calculating that thing into some infinite decimals. Okay, you aren't, okay? What's nice after that is notice it gives you a p-value though, okay? Because notice step 2 of 3 just says make a decision. Well, that decision is happening now. Okay, so notice we have a p-value of what? Very good, 0.007. But what level of significance are we looking at? 0.10. Which one is larger? What does that mean? I don't know, y'all tell me, you're the one gonna take a final, not me, I've already passed this class.
You would check the, no.
Hmm?
You would check the no.
Do we reject? Let's check our notes here. Reject the null hypothesis. Perfect. There you go. Here, this says reject the null. But now what would you do on your paper though? You need to see, remember, this is a two-tailed test. Right? So you come in here, and that means you have some rejection regions on both sides of this. Okay. If you go look up, anybody have, let me see your book real fast. If you go look up your book, you can also use your inverse T button. But if you look at the very back of your book, you're going to have all these levels of significance right here. Okay, right up here at the top. And then right here, you're gonna have, oh, we go down to 17. Actually, not 17, we're gonna go to what? 16, right? Correct, Professor. I go to 16 and I'm looking at a how many tail test? Two tail test. So I gotta come over here to my 0.10 and realize that I have 1.746. So notice here, I would have negative 1.746. Here, I would have a positive 1.746. But where does my number fit in? He's where? Dude, he's like way over here at negative 3.692 or negative 3.0101 or something like that if you use your calculator. But either way, this sits deep inside your rejection region. Okay, so no matter what, both ways will give you the correct answer. Okay, it's just with the t-score, you've got to go ahead and look at your table or you've got to do it on your calculator. Remember your calculator, you can use your inverse T button. Okay, so just be warned, just be ready. Well, you know you're rejecting. So if you know you're rejecting, you can automatically say, hey, I don't really want to have to think too hard. So let's get rid of 2 of those. So that way I can make this a coin flip. So tell me, we reject the null hypothesis includes there's sufficient evidence at a 0.10 level of significance, or do we reject the null hypothesis and conclude there is insufficient evidence?
First one.
First one?
Yeah.
You have to have sufficient evidence to reject. That's the goal. Sufficient evidence to reject the null. Okay? Keep going. You do that.
What's that?
I've got a less than. Does anybody disagree? How do you know it's less than?
Significantly lower.
Very good. Significantly lower. That's the guy we're looking for right there. So significantly lower, less than, put that there. And that is what type of test? Left, right, or two-tailed? Left. Left-tailed test. All right. Work out your T-VAE. I'm gonna give you a couple of minutes. I want you to do it both ways. Okay? Draw yourself a normal curve. How would you find certain things? Let's see if you can do it, because you will have no help on the final. So let's see if you can do it now. Everybody remember how to get to your inverse T? Remember that is gonna be the second and then the vars. And then you can go through there, because that'll be where your normal CDF, normal PDF, inverse norm, inverse T buttons are. Well, first things first, keep working. You haven't got it done yet. Notice I'm gonna need a mean. They give it to me. The national mean is 51,494. You keep reading and you find out, okay, good. They give me a sample mean as well of 48,228. They give me a sample standard deviation of 10,287. They did take a number of samples. Number of samples is 33. Notice that is plenty of samples. That's above 30, so they don't have to say the word normally distributed anywhere, so everything's good there. It is always good to know your degrees of freedom, because you're gonna need that if you're gonna be drawing this, and so your degrees of freedom are always n-1, and that's gonna give you a 32. And now we have enough information to start finding our test statistic. Okay, so we have our T is equal to our X bar minus the mean, population mean, divided by the sample standard deviation and the square root of n. Thank goodness for calculators, because you got some kind of big numbers here. Round to 3 decimal places, and you're gonna get -1 1.824. So that would be your test statistic. Negative 1.824. For the process I just did, the way you're gonna be doing that right now, you'll be drawing this, and then you know what type of test is this, left tailed or right tailed? Exactly, it's gonna be a left tailed test. And here's the problem. They give you 0.01 level of significance. That is your alpha. That is the area of the rejection region. Okay, that's what they're giving you. That's what that alpha is right there. The thing is, though, you don't have a T-score for that. Switch over to blue here so we can kind of see it a little better. You need to know what this guy is right here. You got a test statistic, but you need to know what he is. So what you could do, come in here and notice, if you go to your inverse T. Okay, you can put in your 0.01 into your inverse T or look it up on your table. When you do that, you're going to get negative 2.44. Now, when I did my calculator, I get negative 2.449. Okay. But the problem is, where's my test statistic gonna be at? It's gonna be over here somewhere. Okay, it's gonna be at negative 1.824.
Can you go back to where you put in the 0.01 level of significance? I got kind of lost.
Where I put this in, where for the inverse? Not a problem. What you're gonna do is, okay, remember to get to your inverse T, okay? Look at my calculator because I always mess that one up. You gotta hit your shift key. That's gonna be your second key, okay? And then you're going to hit your VARS key or your distribution key. Then go down to inverse T. Notice you have a significant level of 0.01. And then your degrees of freedom are going to be 32. When you do that in your calculator, you're going to get negative 2.448677. Well, you don't know that. Round to three decimal places, and that tells you negative 2.449 is going to be that T value. That is the very beginning of that alpha. Okay, that's where it starts. Okay, it is important to know that because what if you get a, test statistic that matches exactly to that value? Well, that's how come you have a p-value less than or equal to and p greater than. Okay, you got to be able to look at that. So notice, as y'all said, this fell into the fail to reject region. Fail to reject. You're null. Okay. Good on that? Good on the drawing part? Okay. But notice also, and what's nice is this, because on your final, I get it, regardless of what day you take it early, you got an hour and 15. You take it on the final day, you got an hour and 30, or hour and 45. It takes time to draw this stuff out. So maybe you want a faster way. So that's how come we go ahead and do our stat, go to test, go to t-test, and start plugging in all these numbers that we've got here. So we've got a mean of 51,494. We've got an X bar of 48,228. Put in all your information. Be very careful. You'll mess up like I usually do. That, and then hit calculate. And then what is nice is it does give you T values. It gives you all kinds of stuff. Okay, so it gives you that P value. And what does it give you for a P value?
0.03.
I say put everything correctly on my calculator, and I didn't even put it correctly on my calculator. So you always check your work. But notice it does give you a T value. It also gives you that P value. So you can kill two birds with one stone on your calculator. Okay. And I'll be honest, I don't know. Does your calculator, does it draw it for you?
You can.
It can. Have you tried the draw button yet? But it only gives you an area, doesn't it? It just kind of shows you the direction. It doesn't tell you like, hey, here's your guy. You still gotta kind of know where he's at, right? So that's a good little help, a little bit. So notice it does match up. But here, because part 3 says, hey, we're gonna either reject or we're gonna fail to reject. See, for me on this one, I would have gone with a step 2 or a step 3 of 4 and said, okay, what's a p-value? Calculate that. Let me have it. Okay, because they don't ever ask you that. So notice they ask for a p-value here, and you have a p-value of, what do we say?
0.03.
Yeah, 0.039. Well, but then they give us a level of significance of what? 0.01. Well, which one is obviously larger? Yeah. And that correlates with, since the p-value is larger, we are going to go ahead and fail to reject. Okay, so once again, these match up. Fail to reject. Good. So once again, we know we're failing to reject, so let's make the last part easy. Since we're failing to reject, we can immediately come in here and go, well, I can't have that one, and I also can't have that one. So now we're literally at a coin toss, okay? So we fail to reject the null hypothesis and conclude that there's sufficient evidence at a 0.01 level of significance that the mean community college instructor salary in Mississippi is significantly lower than the national mean, or we fail to reject the null hypothesis and conclude there is insufficient evidence. What do y'all think? See, there's insufficient evidence, okay? Hint. Insufficient evidence when you fail to reject. Sufficient evidence to reject. Okay? It is your goal, the sole your purpose, even though you have created a hypothesis, you're not trying to prove yourself, even in science, you're not trying to prove you're right, you're trying to prove they're wrong. Quote unquote, because you've actually proven nothing. Remember, that's what we said exactly in Chan 1. You've actually proven nothing. There's just a high likelihood, or it's a statistical thought that X, Y, Z, whatever you're studying. Okay, so that's what we're debating, basing this on. And how do you feel about 10.3? Okay. Let's jump in to 10.4. All right. Hypothesis testing for population proportions. Once again, going back to things that we learned from 7.1 central limit theorem, because remember, the reason we can kind of trust all this is because we have the central limit theorem to kind of stand on its back, which is why we could do the things we did in 8.1 when we were doing confidence intervals, which is why we can now have those confidence intervals, margins of error, and then go, okay, well, now do I have a p-value? Can I trust that? Okay, well, yes, we can have faith that they work. So, once again, notice this, you're dealing with proportions. Now, be careful. That student talked to me yesterday. I'm not gonna tell you where he was looking at because it would kind of give away things for you on things you're working on. Don't just look at one of these and see a percent symbol somewhere in the question and go, I'm dealing with proportions. You're gonna get it wrong. Okay, because your confidence interval is a proportion. It may say a 12% level of confidence. That is talking nothing of proportion at that point, okay? So you've got to be real careful. Some people get this muscle memory, oh, I see a percent symbol, it's got to be proportions. No, it doesn't. Read it in context, look at it carefully, okay? So like I said, just be careful. Coming in here, notice they give us to say, hey, is the sample size large enough? If it's not large enough, what are they gonna have to say? Okay. You've done all this before. There's some more examples of things that you need to just have as far as like, are these conditions met? Okay. Done all this before, done all this as an A1. And then now notice we are not dealing with T's anymore again. We've gone back to a Z score again, okay? A little bit uglier of a formula to find that Z score. But remember, this would be for your project, which we will do both ways. And then, yes, you're lucky, you do have a calculator button again. So, calculator button for this one is going to be 1 minus prop the test. Not to be confused with 1 minus prop z interval. Okay, some students were using 1 minus prop z test because they just got hooked up on the 1 minus prop. And then they just kind of went to the races after that. I don't know how they filled in the information when they were doing the intervals. Because when you see the prop z test, it asks for different things. So just be careful which one you're using, okay? Prop z interval is whenever your question asks you for confidence intervals. Prop z test is whenever it's going to be saying, hey, we're doing a hypothesis test here, and you're dealing with proportions, okay? Same thing as before. Left-tailed, right-tailed, and two-tailed. Notice nothing's really changed. We've just gone back to Z's. The only way you're going to be using that T-score, the only way, okay, is when sigma, population standard deviation, is unknown. That's the only time you're going to use it. Every other time, you're not. You're going to be using a Z-score, or we're going to go back to that chi-squared in the next chapter. Okay, good news on that one is you do have a calculator button for it though this time, okay? To do these, you're still gonna need to know your rejection regions, which we'll reference back to. They're in your book and I'm gonna give them to you on your final. Be careful with these, because I had a student reach out to me. Here's a question for you. What Z-score is that? Would that be for a right-tailed or a left-tailed test? A right-tailed, because every single one of those is a positive Z-score. But remember, if it was a left-tailed test, that means it's on the negative side. So each one of those will be a negative version of that number right there. So kind of be ready for that, okay? This one, that if you're looking for it in your book, you're gonna look at the front of the book for this. At the very, very front of the book. So that's where your Z-scores were at, and it should be at the very bottom right-hand side. Critical values of Z. Okay, there. Yeah. Yes, you can look them up there. You will be receiving one of these, like I said, on your final. I'll give them to you. The testing center will have them. Proctors will have them, okay? You'll also have a formula sheet. Like I said, I'm gonna go over your review today. They're very in the class, let you kind of see it, because I do want you to see that your review is kind of misleading. Okay, because I'll show you questions and there'll be a formula attached to it at times, and it's not gonna be that way on the test. I don't want you to think, oh, he's gonna give us the formula right there. No, I'm not. I'm gonna give you a list of formulas jumbled up and you don't even know, I'm not gonna have them in order. Okay, so you gotta remember what goes where. And then once again, same thing as before, right? Nothing's changed. That's what's nice about hypothesis. Nothing changes a lot. Okay? The tails are the same, p-values are the same. So let's start working it out. And this is what is it? Step 1 of 7. This is where it gets a little annoying.
Any questions?
I think there's like 6 questions. Yeah,
That's still annoying.
yeah, it's still annoying. So 6 times 7. So you got like 42 questions. But some, you're gonna see some of them are like, dude, there it is up there. You just kind of write it down. You don't have to even think, there it is, okay? So notice on this one though, I'm not giving you that you're dealing with a mean or anything like that. Obviously, you can tell right now because the chapter you're in, people are gonna go, oh, well, obviously it's P. Yeah, people say obviously until you're looking at the final. Okay? But notice right off the bat, okay, like telltale sign that I'm gonna be dealing with proportions. A publisher reports that 38%, okay, of their readers own a particular make of car. That's telling me we're dealing with proportion. Automatically, I'm either gonna be in my head, okay, I'm in either 8.4 or I'm in 10.4. I don't know what the rest of the question says, but there's where my brain just went to, okay, because I'm dealing with proportions. A marketing executive wants to test the claim that the percentage is actually above the reported percentage. A random sample of 350 found that 42% of the readers owned a particular make of car. Is there sufficient evidence at the 0.10 level to support this executive's claims? Okay, step 1, always step 1. You need to state the null and alternative hypothesis. Good news is this. We know we're dealing with a P, but what you do with a P in one, you're always going to deal with a P in the other. The null is always what type of statement? Equality statement, exactly. And so what are we going to put for our unbiased estimator?
Greater than.
I need a number.
38%.
Yeah. Or Hawks is going to want 0.3. And what's good is even at that point, you know that 0.3 is going to go where? On the bottom as well. It's always going to match. It has to. I'm not going to test whether I can solve cancer with milk and then go test everybody with orange juice. That's not how science works. You test everything with the same exact levels, okay? Greater than, less than, or not equal to. How do you know?
Above.
Above, exactly. Look at those little special words. So you just got done. Question 1, there's part 1 of 7. Find the value of the test statistic. Now, I'm gonna warn you. This is not as cut and dry. Okay? It is simple, but it's not as cut and dry. I'm gonna show you the p-value first. Okay, and then we're gonna work it out in our calculator to make sure you're getting the same thing, because this has got a lot of junk happening if you remember that formula, okay? So if you look at your 1 minus prop z test on your calculator, okay? So once again, stat test, scroll down to 1 minus prop z test. You have a p sub 0. That is always, okay, the number you're using from step 1. That's 0.38, okay, or whatever number they're giving you. It's going to be the main claim, okay? So we have a 0.38. And then your calculator is going to give you an X, an N, and then a P. What is your N?
350.
That. And here's the trick. What's your X?
147.
Huh?
147.
147. How'd you get that?
I what 42% of 350 is.
Exactly. You have to do that 42% of 350. Okay, that's your X. Because realize what your calculator is doing. It's calculating that 42% for you. Okay. There's nowhere in there you ever explicitly put the 42%. Okay? So you can do this one, two ways. Do the math, or you can literally put in 0.42 times 350, and it'll do the math for you in that. But she is completely right. It is 147. And then we're doing what? Less than, greater than, or not equal to? Yeah, it's gonna be greater than that P of I. Very good. Listen to mine. And you should have got 1.54. Okay. Notice you're rounding to 2 decimal places. Okay. So there is your test statistic, 1.54. Well, what if you're doing this on your project paper? There's a possibility that one of your project papers is dealing with proportion. I don't know, maybe it is, maybe it's not. I don't know. I'll wait till you turn in and see if you got it right or not. But realize that you are still dealing with this right here. And we do know that we're dealing with something that's greater than. Okay? Greater than is gonna be here. But this one, they give you a chart. Okay? Notice it says at a 0.10 level of significance. If you go look on your book, or if you go all the way back to this chart right there, notice I'm looking for that 0.10, and here it is right here. 1.28 is going to be the z-score that correlates exactly to that right there. So even before we get to the very end of this question, we could already know what. Because I just found the z-score for mine, right? Which is what? 1.54. But this thing starts at 1.28, so where do I fall? Do I fall on the fail to reject, or do I fall into the rejection region? Yeah. You're falling into that right there because 1.54 is going to sit inside there. So we can automatically know that we are going to be rejecting. The no. Everybody good with that? Are you okay with doing that now? I mean, the drawing should be getting easier and easier, okay? You can also hit draw, like I said, on your calculator. At least it'll give you an idea, okay? And there you go, look at that. Easy question. Specify test, 1-tail test or 2-tail? 1-tail, exactly. There you go, so you can skip past that one pretty quick. And then determine the p-value. Oh, did they give you a p-value? Yes. What was the p-value? Rounded to 4 decimal places. Be very careful if you're going to miss anything on Hawks. It's going to be because of that rounding probably.
0.06. What is it? 0.0616.
Very good. And see, that's what I do like about the proportional is they ask you for the p-value so that way you know it. I think they could make this a lot more, way better. They could start making it where you could do area and all kinds of stuff. We should put our offer with that guy. Identify the value of the level of significance. What is it? Huh? 0 point. That will probably, I'm gonna be honest with you, Hawks is finicky. That will get you a wrong answer. Yeah. Don't forget the 0. How many questions y'all miss on your homework because you didn't put 0 at the end of it sometimes? It happens. Okay. If it happens on your test, I'll see it and I'll be like, they meant to put 0. I'll give you full credit for it. Okay. But that needs to become something you do. Okay. Well, what are you doing? Are you rejecting? Or are you failing to reject?
Rejecting.
Rejecting. So notice a lot of these 6 of 7 are actually very simple, just like after step 2, you already kind of know everything you need to know after that point. Okay. And it's just a click through. Okay. And then right here, you're going to state the conclusion. okay? Which obviously they're gonna give you 4, but I wanted to see if you could say it. We would be doing what? Automatically, if they give you 4 choices, what are the choices you're gonna get rid of immediately?
Fail to reject.
Fail to reject. You can get rid of that immediately. You can go, okay, you know what? I'm not gonna be using those because I'm not failing to reject. I am rejecting, okay? So we know we're rejecting. Why?
Sufficient.
Because what?
Sufficient.
Yes. There is sufficient evidence. When you are rejecting the null, you have found sufficient evidence or a high probability that what?
38%.
The null is false, basically, right? Because you're rejecting. You're saying, that's not going to be correct. Once again, did you really prove anything at all? No, it's all probabilities. Okay, you need to kind of know that. Okay. So, look at that word, sufficient. See if I can spell it right. I did, maybe. I misspelled symmetry for half this class. But I'm not an English teacher, so I don't care. None of y'all caught it ever. SYMM, not SYM. Good job. And that's really how 10-4 is gonna go. Okay. And that's everything that's due this week. Don't forget, I got rid of your chapter 8, 10 test. You don't have to worry about that one anymore. It is gone. Okay? Yeah, I'm a nice guy. So very quickly, I'm gonna get in here. I'm gonna start showing you some of your final.
Cause it's, the Z and A is not already, this is for chapter. Right here. No, it's if you look at this one again. Oh, there's no little. Where it fell. You check this. That's no. Where? It's a, yeah, because. There's no. No, one of that is.
Let's take a look at this. Notice you have a question like question 1. Now, mind you, this is not an exhaustive list of questions you're gonna have on your final. Okay? This is a list of the hardest questions you're going to have on the final. Okay? The other questions are really gonna be probably questions you're gonna be just fine with. Okay? Promise. Okay? These are the ones that you actually gotta do a lot of thinking over. Okay, like this one right here, the weights of steers in a herd are distributed normally. The variance is 90,000 and the mean steer weight is 800 pounds. Find the probability that the weight of a randomly selected steer is between 1,040 and 1,460 pounds. Round your answer to 4 decimal places. This is where I talk about. Now, this is question 1 on your review. This might be question number 15 on your final. Okay, because I think your final is 15 questions. Okay. So you gotta think about it. Are you doing some sort of interval? Are they asking you for a hypothesis? No. You have to look at it very carefully, okay, and start deciding. And then, okay, are you gonna use a formula? Or are you gonna use your calculator? If you're gonna use your calculator, what kind of calculator button would you use on one like this? Notice. Hint, hint. It's a confidence interval. Or it's just actually, it's just an interval. This is going all the way back to chapter 6. When you first started learning, remember when I started teaching about those upper bounds and lower bounds? You're just trying to find the area under the curve. Now, if you decide to use your chart in your book, what would you have to do first if you decide to use just this chart? Let me see that. If you decide to use this guy right here, what's the problem with those numbers?
Not gonna be.
What? Your final, not mine. Why would these numbers not be in there? Think about it. This is a normal curve, right? What do you have to do first before you start looking at your chart? Standardize it. Okay? You're gonna have to turn each one of those into a z-score and then start doing the area from there. Or, I think you might want to write this down, normal CDF. Upper bound, lower bound, remember when we were doing that 1 to the 99 and stuff like that? This one actually has an upper bound and lower bound that's right there. There's your lower bound, there's your upper bound, there's your mean. Does it give you, oh, sorry, there's your, what did your calculator not give you? Never ask you for variance. What do you gotta do to that guy? Square root of it. So you gotta be careful. Keep going here. With this, what value, this is a good question. I'm actually surprised I could put this in your final. What value of Z divides the standard normal distribution so that half the area is on one side and half the area is on the other? Round your answer to 2 decimal places.
Zero.
Yeah, it's a 0. Because you've standardized it. The mean is always what when you standardize? 0, that's the halfway point. That's how come you have that. Remember the standard deviation of 1, 2, 3, -1, -2, -3. That's how come we can take the area. What else here? Length of nails are normally distributed. Here we are. There's one there. Philosophy professor of signs, letter grades. I know y'all loved that one. And remember, every single question on your test, every one of them, is in your homework. I don't make up questions. They're all, you've done all these in your homework. Okay. There's one that can be deceiving. Look at this. I do give you the formula on this question. Okay. I do not give it to you on the test. You will not see a formula attached to any question. Now in Hawks, they'll give you tables as well. I'm going to give you printed off versions as well, because sometimes the hot ones in Hawks can be kind of confusing to use. You'll just have them right there on a paper. Okay. So, but notice this one is telling you, hey, there's your mean, there's your standard deviation. Figure it out. Okay. Again, there's that one there. Law of normal, there's one right here. The Dray Mail Company wishes to estimate the proportion of people on a large mailing list that will purchase a product. Suppose the true proportion is 0.07. Okay, be careful. Do not forget that in some of these, especially with proportions and stuff like that, remember in chapter 7 when y'all started learning continuity correction? Some of these you're going to have to realize that there's going to be some continuity correction. Remember where you'd have like a lower bound that started here, upper bound here, okay? Or it would have to be that little bit of a plus or minus of 0.5. You gotta be careful about some of those, okay? Minimum number. Search company, there you go, there's that one. Finding T values. Know how to you need to know how to use your list function. Okay, because sometimes I won't give you a standard deviation. Sometimes I'm going to say, hey, here's some data. Now give me everything else I need. Okay, and so you have to put it, we have to put it in your list. When you get down toward the end here, you will start noticing like there's your chi-squared. Remember 8.5, there is no calculator button. Okay, that's when you start learning about that chi-square distribution. I will be honest with you, the hypothesis testing for variance and standard deviation, we do have a button. Okay, so good news about that. I say that, mine has a button. I think yours does too. It should be chi-squared PDF. It'll be in your test section. Okay. And then there you go. Now you start getting, and that's a That needs to be corrected. If anybody does 26, I'll let you know. Well, you probably, well, tell you what, no, I shouldn't have to correct that because what should that be? You can go in there and go, okay, somebody put zeros in. I don't know why I did zeros. It's a formatting issue. But you can go in there and go, I can figure out it's less than, greater than, or whatever. Keep going down and then all of these down here, there's your chi-squared. And then right here's chapter 12. We'll get into that next week. But you can kind of have a look at what it says. Determine if the correlation between two given variables is likely to be positive or negative, or if they are not likely to display a linear relationship. Okay. Gotta draw, on Hawks, you will be having to draw a graph. You'll just plot points. Okay. Find out the correlation coefficient of R, round your answer to 3 decimal places. It's a simple little formula. Okay, once I show it to you, you're gonna be able to like plug and chug, you're good. Okay. And determine whether the given correlation coefficient is statistically significant at that specified level. Okay. And like I said, we'll learn about all that next week, 12.1 and 12.2. Any questions over what your review looked like? Are you good with it? Okay. 10-4, everything's due Sunday. 10-5, we'll get it started on Tuesday. Finish up. Got one more week for finals.